Picture this. You're managing hundreds of files in a web app, or dragging across a Kanban board to move multiple cards at once, only to discover you can't select more than one item without tediously clicking each one. That friction slows users down and kills productivity. But what if you could deliver the same smooth, efficient multi-item selection that users expect from desktop apps, directly in your web interface, without depending on heavy third-party libraries? In this tutorial, you'll learn exactly how to implement powerful drag-to-select functionality using just modern vanilla JavaScript and CSS. You'll discover how to create a fast, visually polished selection rectangle, accurately detect which items are inside the user's drag area, and provide real-time visual feedback as users select, add, or remove items. We'll cover best practices for handling performance, modifier keys, and accessibility, all while keeping your bundle size lean and your codebase fully in your control. This skill isn't just a technical trick, it's a critical UX pattern for building feature-rich file managers, data grids, project boards, photo galleries, and any interface where users want to work smarter, not harder. Mastering drag to select will set your projects apart, boost engagement, and make your applications feel truly professional. If you want to keep building next-level user-friendly web apps, make sure to subscribe for more in-depth, modern JavaScript tutorials. Staying up to date with our channel means you'll always have the latest techniques and best practices at your fingertips, helping you deliver exceptional user experiences every time. Imagine you're organizing a box full of index cards, each representing an item in a digital list or grid, photos, emails, files, or notes. Traditionally, you might pick out a handful of cards one by one. But what if you could simply wave your hand over a section of cards, gathering them all at once? This is the essence of drag to select, a user interaction paradigm that brings the fluidity and efficiency of physical selection into the digital realm. In graphical user interfaces, this experience is most commonly visualized by a translucent rectangle known as the selection rectangle, marquee, or lasso, drawn over a group of items as the user clicks and drags. Items intersected by this rectangle become highlighted or selected, ready for batch actions like moving, deleting, or editing. The power of drag to select lies in its immediacy and intuitiveness. It mirrors how we interact with objects in the physical world, reducing friction and mental load. For example, in a file browser, instead of individually checking boxes beside each file to select multiple items, you can simply draw a rectangle around a cluster, instantly grouping them for your next operation. This pattern is not limited to file management. It extends to photo galleries, spreadsheets, Kanban boards, and even creative tools like vector editors. The visual and tactile feedback provided by the selection rectangle helps users understand which items are being affected, minimizing errors and enhancing confidence. Conceptually, drag to select serves as a bridge between direct manipulation and batch processing, making complex actions feel as simple as a flick of the wrist. It transforms the act of selection from a repetitive, granular task into a fluid, spatial gesture, aligning digital interfaces more closely with the way we naturally interact with groups of objects. At the core of drag to select functionality is the challenge of accurately detecting which items fall within the dynamic boundaries of a user's selection rectangle, a process known as hit testing or collision detection. To understand this, picture a transparent sheet being laid over a table of objects. As the sheet moves or changes shape, you must determine which objects are fully or partially covered by it. In web development, this means calculating whether the bounding boxes of DOM elements, each selectable item, overlap with the coordinates of the selection rectangle. This operation must be both precise and efficient, especially as the number of items grows. Each item has a rectangular region defined by its top, left, right, and bottom coordinates relative to a common container. The selection rectangle, drawn by the user's mouse drag, is similarly defined by its start and end points. The hit testing algorithm compares these rectangles. If they intersect, the item is considered selected. For lists or grids with hundreds or thousands of items, This process can quickly become computationally expensive. Efficient implementations minimize unnecessary DOM queries, cache bounding boxes, and may throttle event handling to ensure smooth performance. Furthermore, complexities arise with scrolling containers, nested layouts, or responsive designs, where positions shift dynamically. The robustness of drag-to-select depends on consistently translating user input, regardless of scrolling, zooming, or device pixel ratios, into accurate selection feedback. In practice, this means aligning all calculations to the same coordinate system, carefully managing scroll offsets, and testing edge cases where selection rectangles partially overlap items. By mastering hit testing, developers enable drag-to-select to feel effortless, responsive, and reliable, replicating the precision of physical selection in a digital environment. This is the core logic and UI for implementing drag-to-select functionality in a modern front-end list grid using only vanilla JavaScript and DOM APIs. The code below generates a selectable grid, manages selection state, renders the selection rectangle, handles mouse, touch events, and supports keyboard accessibility enhancements. Key concepts demonstrated: dynamic generation of selectable items with unique IDs, state management for drag operations and selection sets, accurate hit testing between the marquee rectangle and item bounds, modifier key support for additive, subtractive selection, responsive visual feedback for both selection and the marquee, basic touch and keyboard accessibility support. This file defines the HTML structure for the drag-to-select demo. The layout includes a container for selectable items, a floating selection rectangle, and a script reference. The grid is styled for usability, and the selection rectangle overlay is positioned absolutely for accurate marquee rendering. Key elements: the selectable area div acts as the interactive grid container. The selection rectangle div is the marquee overlay. Script inclusion at the end ensures DOM is ready for JavaScript. This file contains the CSS styles for the drag-to-select grid, items, and selection rectangle. Styles ensure a clear, modern UI with proper feedback for selection and marquee actions. It also sets up a responsive grid layout for the selectable area and includes transitions for visual smoothness. Key CSS highlights: selectable area uses CSS grid for a responsive layout. Selectable item.selected visually distinguishes selected items. Selection rectangle provides a translucent dashed marquee overlay. This file provides an optional configuration for development tooling, including scripts for serving the demo locally and running automated tests. It lists development dependencies required for Jest and JSDOM, enabling unit and integration testing of the drag-to-select implementation. Key fields: scripts, simple commands for local development and testing, dev dependencies, testing and DOM simulation libraries, and library. The page displays a modern drag-to-select demo interface featuring a grid of selectable items, arranged within a bordered, resizable area. Above or beside the grid, controls allow the user to adjust the number of rows and columns displayed. The user increases the number of rows by interacting with the row's range input, causing the grid to expand vertically as more items are added. Next, the user increases the number of columns, and the grid expands horizontally, visually accommodating the new structure. The changes are visible in real time, making it clear how the grid size and item arrangement adapt to these controls. Following the grid adjustments, the user pauses to let the new layout settle. Then, to demonstrate core drag-to-select functionality, the user starts a selection at the grid's top left, clicks, holds, and drags diagonally toward the middle right. A translucent selection rectangle appears and dynamically resizes to track the pointer, visually highlighting all grid items currently within the rectangle's bounds. When the user releases the mouse button, the highlighted items remain selected, indicated by their color and styling. At this point, a live area region updates, announcing the number of items selected for accessibility. Next, the user demonstrates additive selection. By holding the Shift key, the user clicks and drags a second rectangle in a different part of the grid. As the rectangle covers more items, those not already selected are added to the selection in real time, joining the previously selected group. Upon releasing the mouse, these new items remain highlighted, and the live region reflects the increased selection count. The user then showcases subtractive selection by holding the Ctrl key or Command key on Mac, clicking, and dragging a rectangle over a portion of the grid containing already selected items. As the rectangle passes over these items, they are visually unselected, returning to their default appearance. Releasing the mouse finalizes the deselection, and the ARIA region updates with the new selection count. To demonstrate toggling individual selection, the user continues to hold the Ctrl or Command key and clicks on a single grid item. If the item was selected, it becomes unselected. If not, it becomes selected. The visual state of that item updates instantly, and the ARIA region announces the change. For bulk selection, the user first clicks the Clear button to remove all selections, making every item return to its unselected state. Then, the user clicks the Select All button, and all items in the grid become selected at once, each visually highlighted. The ARIA region confirms the total selection. The user clicks Clear again, resetting the grid to no selected items. Demonstrating keyboard accessibility, the user focuses the grid, holds Ctrl or Command, and presses A. Instantly, all items are selected, mimicking the effect of the Select All button, and the ARIA region provides feedback. Keyboard navigation within the grid is then demonstrated. With the grid focused, the user presses Tab to focus the first item, uses arrow right twice, and arrow down once to move focus to a specific item, and presses the space bar to select that focused item. The item changes its appearance to indicate selection. To demonstrate the responsive design, the viewport is resized to a mobile-friendly width. The grid layout adapts, stacking items and controls appropriately for the smaller screen. On this mobile layout, the user performs a drag to select gesture by clicking and dragging from one corner of the grid to another. The selection rectangle appears and highlights items as before, showing that the drag to select interaction remains smooth and intuitive on mobile-sized screens. The selection is finalized upon releasing the mouse, and the ARIA region reflects the change. Throughout, each user action, whether adjusting the grid, selecting with the mouse, using modifier keys, or navigating with the keyboard, triggers immediate visual and ARIA updates, reinforcing the grid's interactive, accessible, and responsive drag-to-select capabilities. The demonstration ends after these interactions, leaving the grid in its current selected state. You've just unlocked a game-changing technique for modern web development, building drag-to-select multi-item selection from scratch without the bloat of libraries. This skill puts you in full control. Blazing fast selection, seamless integration into any stack, and the ability to craft exactly the user experience your app deserves. Imagine the difference when users can select, organize, and interact with lists and grids as smoothly as in desktop apps, because you made it possible. Ready to take this further? Try adding your own touches, like keyboard navigation or touch gestures, and see how quickly your interfaces stand out. To keep accessing powerful, practical tutorials packed with real-world code you can use right away, hit subscribe now. You'll accelerate your learning curve and become the developer everyone relies on for robust, pro-level UI features.